Alright, hello again. In this lecture, we're going to learn about the greatest common factor, or the GCF. First thing we're going to start off with is some ugly numbers. We have 30, 54, and 72. In order to find the GCF, we can sometimes just look at the number and figure out what the GCF will be from them, or we can use kind of a concrete method by taking the prime factorization of each number. So, when we look at 30, we'll break it down into its prime factorization. Since 30 is not prime, it can break down into two things other than one in itself. So 3 and 10 is probably one of the easier ones. If you did 5 and 6, that's fine too. 3 is prime, so that's the end of that tree. And 10 can break down into 2 and 5. Since 2 is prime, you can't go any further, and neither with 5. And that's it for that tree. Now hold on to it. I'm going to draw a line here so we can kind of split it up. Now we'll look at 54. Two numbers that can go into 54. Probably 6 and 9 is what jumps out at me. If you did 2 and 27, that works as well, whatever you prefer. So 6 is not prime, it breaks down to 2 and 3. They are prime, so we'll stop there. And 9 we can break down further. Usually students make the mistake where they think 9 is prime, but 3 can multiply by itself and get us 9, so make sure you don't make that boo-boo. And last but not least, we have 72, which can break down into 9 and 8. Or you could do 2 into it, or any other crazy combination you come up with. 9 isn't prime, it breaks down to 3 and 3. 3 is prime. 8 can break down to 2 and 4. 2 is prime, so that's the end of the road there. 4 breaks down to 2 and 2. And now what we're going to do is collect what they all share. So, 30 has a 3, 54 has a 3, and 72 has a 3. They all share a 3. So far, part of my GCF, I am collecting a 3. 30 has a 2, 54 has a 2, and last but not least, 72 has a 2. So they all collect a 2. And I'm usually using the smallest number to try to figure out what they all share. Since there's no more 3's here, I can't take another 3 because 30 doesn't have any more to give. There's no more 2's. Now I'll check 5. There's no 5's in 54, so right away that's not a common factor, so not included. So our GCF is going to be 3 times 2, and we get 6. Now variables are a little bit easier than numbers, and this is how we'll do numbers. Either you can figure it out by kind of guessing, starting with the smallest number, what can go in there that will also go in the others, or you do the prime factorization. For variables, it's nice. We have the GCF for each variable is the smallest degree of that variable. So let's say, for example, we are asked to find the GCF. Oof, my C is ugly. Sorry about that. And we have, I don't know, crazy stuff. X to the 4th, y cubed, maybe x to the 6th, y, and xy to the 7th. So, each variable, we look at each one separately. So we have the x's, and what we're doing to do is collect the smallest degree of that variable. We have an x to the 4th, x to the 6th, and x. X is the smallest degree, because x can go into x to the 6th. In fact, there's 6 x's here, so one of them we could take away. Same deal here, there's 4 of them total, we could take out 1. So far our GCF has 1x. Now we're going to look at the y's. We have y cubed, we have y to the 1st, and y to the 7th. Smallest degree is y, so that's what we collect, so our GCF is xy. Or you could write yx, it doesn't matter what order. So that's how we find the GCF for variables. Very nice. Now what we're going to do is factor. And we're just going to factor general polynomials. Factoring, you got to think of, is backwards distributive law. Distributive law says we have a times b plus c, and you take that a and you distribute it to each term. So you'll have a times b plus a times c. So let's start off nice where we are asked to factor, and let's give ourselves a really nice polynomial. Let's say we have 15x squared plus 15x. Now our first step is to find the GCF that they share in common. So we're going to look at each term separately. We'll look at 5x squared and 15x, both separately. Start with the constants. They're usually the easier ones to work with. Since 5 is the smallest one and he's already prime, can he go into 15? Yeah, he can go in there 3 times. So 5 is definitely something we have in common. And now let's look at the variables. We have x squared and just x. Smallest degree wins, so we have x. That means our GCF is 5x. So we're going to factor that out. I'm going to write this a little bit funky just so you can get used to it. I'm going to write 5x squared as 5x times something. Well, I already took care of the 5. I have a single x, and x times x gets me x squared. So that's the same thing. Plus, and I'm going to do the same thing to 15x. I want to write it as 5x times something. Well, I already have the x, and 5 times 3 gets me 15. So now I'm going to factor out that GCF. And when I do this, I'm going to have to write parentheses around what's left over, because it's backwards distributive law. So I'm going to need the 2 terms in there. So we'll have x plus 3 is what's left over. And now we're done. Since that might have been a little too nice, let's do one more. And let's see where we're asked to factor. (30m to the 9th minus 30m to the 5th minus 54m to the 2nd. So it's the same deal. I'm looking at 30, since he's already the smallest number. And I'm trying to think of things that can go into 30 that can also go into 54. And I already kind of did 30's prime factorization. I'm just going to loosely do it here. We got 3 and 10, 2 and 5. I know 30 can go into itself, so that's already pretty nice. But 30 can't go into 54. So, I'm going to see, can 3 go into 54? Yeah, 5 plus 4 is 9. 3 can go into that, so that works. 2 can go into 54 because it ends in an even, but 5 can't. Which, actually, I could probably already see 6 times 9 there, and 3 times 2 is 6. So, 6 is going to be our GCF. So we'll pull that out. Now let's look at the variables. We have m to the 9th, m to the 5th, and m squared. So we're going to take the smallest degree, which is m squared, and left behind, we need 6 times 5 to get us 30. We have m squared, we want m to the 9th, so we need 7 more m, minus 6 times 5 gets us 30. We have m squared, we want m to the 5th, so we need 3 more m's. Minus again. 6 times 9 gets us 54. And we already have m squared, so we don't need it. And now we're done. And that's all for now.